Hello, guys. Glad to have another session. I'm still in the university from the afternoon. I know most of you were sleeping from that time. It was your night, and now it's your morning. It's late night here. I mean, it's midnight now. It's 12 a.m. How are you doing, guys? I see an issue. Why on websites we are not updated? The stream is not updated on the website. Okay, so we have to for now continue on YouTube until the website gets updated. This is the first time that during the live stream I should fix something. And guys, I have a news that I see the bad news. We have to postpone the contests probably till the weekend. Well, there's a good side to it that it's gonna be on weekends. It's gonna be on Saturday. But there's a bad news to it that it's going to be postponed, and postponing is always not good. We just want to ensure that we can have the contest with the best quality, and in order to ensure that our websites can host everyone at the same time very well, it won't have any issues, and the problems are going to be in the best shape, etc. It's the best choice for us to postpone it. So sorry for that. I hope that's gonna be okay. Hi. Hi, guys. We're gonna start talking. Guys, did you have a chance to invite other people to take a look at Repovive as well? If we can actually, I know that one of the challenges that is in my mind right now is that we are trying to build something really cool, something really big. And guys, just look at what is behind me. We are planning for CF or competitive programming roadmap. So we are trying to build that in the best possible way that can actually help you a lot. But that's just one part of it. Another part of it is that to make people aware of it, that we are doing this. And that's the part that you as the first members of Repovive who are, Repovive is yours actually. If you want that, if you want to be a part of that, I would really love it actually. So, even in the teams, you can see that. See, I have a team for Repovive that anyone can join. I don't know why on the websites it doesn't show me, and it's better if I leave that and continue just on YouTube this time. We have to market it on Instagram. No, I think if you have any friends or anyone who you think that they actually see, we only want people who will benefit from it. That's the main thing that we want. People who actually benefit from Repovive. Because if someone does not benefit, it's not meaningful. What do they want to do? You know? Bro, you speak like Habib. Do I? I have never listened to Habib speaking. Hello everyone, recovering from last contest. Where are you from? Yes, it's the contest on Repovive, but we're gonna postpone it to Saturday, unfortunately. So is this playing that? Yes, on website it's playing last stream. I wanted to fix that, but I left that for now. Today, we're gonna be only on YouTube. Unfortunately, even though I like it that much, I liked the website much better as well. Guys, by the way, we have if in case you have not joined the bootcamp yet, we have the bootcamp here. In the website, if you haven't joined that yet, Make sure you join there, and this way you can both ask your questions in the discussion section. Now I have answered your questions. I think the last one was left. I mean, there's I'm gonna answer that too. And the problems are all visible here as well. And whenever you accepted the problem, you can just mark it that you have accepted, and you can see that how everyone have worked on it. You can either register as an anonymous person or register as one of the people who other people can see you. And I got a lot of great feedbacks. I don't know. On LinkedIn, I'm starting to talk to many new people and getting feedback that how is it going. I don't know. Have we discussed on LinkedIn so far? I talked to a lot of people recently to get some feedback and about how can we make Repovive actually better and more useful. I would love to keep getting feedback from you. Just update the playlist there. The playlist is also updated there. We have the 3 sessions, I guess. I don't know why the thumbnail is just not shown on this one. I will check that out too. Okay, so we can sync the CF submissions rather than marking it individually. Yes, we can do that. The point is that there's a lot that we can do. We need to see that which one is actually has the most effect. That's one thing, but I'm thinking about how much that changes the way you're learning. You know, that's the point. I agree that that's a cool thing though, but I'm not sure how much it helps you guys. That's why, I mean, we definitely move on to that, but you are trying to prioritize things. We were very focused on first debugging some of the issues that we have, and second, also on the roadmap. I was also busy spending some time talking to people and getting feedback from them. Anyway, if you are ready, we can start talking about the problems today. The link to all the problems are here in the problems section of the camp. You can see all of them. These are the last 5 problems that are right now on top. And we're going to go over them one by one. If you come with me at the end of this camp, you can definitely have a jump in your rating. Maybe it doesn't happen in one contest that you're unlucky, but you definitely feel the change, and you will sooner or later, you will see in the contest that's. But I mean, I don't want you to really listen my words. At the end, I will actually take a survey from you. That's how much do you think that the camp was actually useful for you. And I see that if you really feel it personally or not. I don't know how much so far the camp was useful for you, but we definitely, at the end of it, talk more about it and know that, to understand that how actually it was useful for you. Okay, let's start talking about the first problem. Let's move on to the problems fast. We want to solve all 5 problems. Let me see that. Why do I have a tab that is sending me notifications? Sorry for that. Okay, so the first problem is this one, Ehab and prefix sums. Guys, this problem says that given an array A of length n, find another array B of length n such that for each I from 1 to n, mix of B1 to Bi is equal to Ai. The mix of a set of integers is the smallest non-negative integer that doesn't belong to this set. If such array doesn't exist, determine this. Okay, so mix just means the minimum number that is not inside there. Yeah, I get it. The camp was useful. I solved it. Awesome. Great to hear that. Great to hear that. All the problems, guys, are here. I just put them there so that it's not necessary to send them one by one. But if you want, you want the link of this specific problem, I sent it again. But in general, they are all here. I mean, You can just see it here. So this problem, Ehab and prefix sums, actually says that we want that for each I, the mix of those integers is the mix of the first I integers is actually equal to AI. And we are given A1 to AN. So, guys, if you take a look at these numbers, at each position, you can look at all the numbers. For example, assume that we are in this position, position 1. What I would say is that at position 1, you cannot have any of the values that appeared in the array. You cannot have any of the elements that appeared in the array in the first place. Why? Because at some points, those values should be a mix. Any value that is in AIs at some points should be the mix. So they should not be in the array. Because if they are in the array, they will never be the mix. They should not be the first element in the array. They should not be in any of those prefixes. Do you agree with that? For example, in the first position, none of AIs can come in the first position. For example, if you take a look at it, look at this. In the first position in this one, we cannot have 1 or 2 or 3 because 1 or 2 or 3 it should be a mix later on. I'm just talking about the first position. Also in here, in the first position, we cannot have a 0 or 2 as the value because otherwise they won't be a mix later on. If you agree with it, please put a plus or use this emoji. Yeah, that's great. That's actually great to hear. I'm glad to hear that. I hope that you see the results in the contest soon as well. Awesome. So now what I say is that, okay, do you agree that also for the second element, it cannot be A2 to AN? It cannot be A1. A1 is okay, but anything that appears from A2 to AN, still it cannot be done. And again, at position 3, it cannot be anything from A3 to AN, and so on. Now, I use a greedy approach. I say that at each position, we know that what values it should not be. We know some values each time that we know that it should not be any of those values. I say that we have to put the optimal case to choose is the minimum number that we can put here and we don't have it already. Each time the best choice that we have is to choose the minimum number that is not already there and it's not in AIs as well. It's not. We have not it in AIs at all, and preferably we don't have it in BIs as well. Why? Because this way I can construct the values from top down, and also, I mean, I'm filling these gaps, and we know that it's okay to fill these gaps because they are never useful. They are never going to be the mix. And the more that I can fill these gaps from the bottom, the more I have the chance to, whenever I want, have one of these as my mix. Okay. And the point is that mix should be in increasing order. So, I mean, if it decreases, it definitely is not possible. So it's the best to always choose the minimum number and start filling the gaps from there. Each time choose the minimum number that is not in AIs to the right of it, and it's not in the BI so far as well. And then this way, greedily, we can build the sequence. And at the end, we should just check. We should just check and see that if this would actually give us these mixes. If it would, then that's the answer. Otherwise, the answer is -1. Is it clear or not? I want to first know your opinion. And then I'm going to run it on a sample as well. I want to first know your opinion and see that's what you believe. Yeah, sure. I will repeat it. I will repeat it once again. I just want to get a feedback from you to see that which ones of you understood it, which ones of you didn't understand it. And then we will talk, we will run it also on an example. Okay, so yes, we will. For now, basically the problems from Codeforces are so far, especially when you are starting to learn, Codeforces is enough for you, and it's gonna be mostly a distraction to focus on other jobs. But yes, definitely as we go forward, there are some problems that we should solve. For example, from Spudge, from other places. Let me run it on a sample. Run this on a sample. Assume that your mix, for example, your mixes are one, one, three, 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 and four. How do I build this? How do I make sure that, and guys, definitely first of all, your mix should be increasing. If your mix is not in increasing order, that's impossible, because it's not possible that the mix of this one is something, this prefix, but a mix of a greater sub prefix is something smaller than that. That's a contradiction, because if this number has not appeared in here, how it appeared here that we have a greater mix? Okay, so the sequence of mixes should always, mixes of prefixes should always be in increasing order. So far, do you agree with that? I mean, it should definitely be in increasing order. Now let me run the algorithm that I'm saying. I'm saying that each time, first of all, I say that we have 1 and 3 and 4. These are the numbers that we should not choose. So we are not going to choose them for here. What is the number that I'm going to put here? First, I'm going to put 0, because 0 is the smallest number that is not in this set. And I can fill this gap now with it. And you can see that the mix automatically becomes 1. In here, 0 is already covered. I choose and 1 should not be selected. Now I choose the minimum remaining number. So I should choose 2. And I fill this gap too. And then 2 will be here. Then I come here and I see that, okay, 1 is okay now. 1, there's no issue with 1 anymore, because from now on, we are not going to see 1 later on in the future. So 1 can appear now too, and it's the minimum number that can appear. So I will put 1 here. And I fill this place now, because 1 is not going to be mixed anymore. And then in here, I have 3. 3 and 4, I'm going to see 4 in the future as well. So the minimum number that is not in the list is 5. I will put 5 here. Then still I have 3 and 4, so I should have 6. Then I still have 3 and 4, so I should have 7. The minimum number that is not there is 7. And then I see that 3 is now free. I mean, I can put a 3. So at the end, I will put 3, because it now can appear, and we will put it here. We do this, and then we start from the beginning, and then see that if mixes are correct, if really we have these mixes. And mixes, I mean, mix is very easy to calculate. You can just keep a CNT that says that how many of each number we have seen. And your mix can be like this. Your mix can start from 0. Each time you can say that while CNT of mix plus plus. While we have this current mix, add 1 to mix. And this way, mix will stop exactly in the first position that we don't have it yet. And if the area of mixes was exactly this, that's good. I mean, that's the correct solution. Otherwise, it's not possible. Yes. When the number stops appearing in the future, it means that it's not going to be a mix in the future. So it's okay. Texas was behind my webcam. That's a bad thing. That's bad. And wherever I put my I put my webcam, still somehow it will actually be somehow covering one of these texts. Left down corner. It was. I mean, I remember when it was in left down corner. Still, it was problematic at some point, especially in the problem statements. Sometimes it was not visible. But anyway, Let's get back to here. So again, when we have three, we don't see three anymore in here. For example, three becomes three. So three is going to be the minimum number that we're going to choose here. So that's how we will move on. Each time we will see that what numbers are we are going to see as a mix in the future. We will make sure to not choosing them because they are going to appear as a mix. So if we actually choose them, then the issue that happens is that they are not going to be a mix anymore because they can never be the smallest number that has not appeared because they have appeared. So, I mean, that doesn't make sense. So that's all about this. Is it clear or not? Do you find it clear or do you find it's not clear? Kind of example on -1 case. Yes. Awesome. Let me also show you on a negative case. For example, a negative case is going to be like this. For example, assume that I have 1, 1, 3, 2, for example. Then what happens? In the first place, I should choose the minimum number that is not in here. So it should put 0. In the second place, I should choose the minimum number that is not here. I should choose 4. In here, I should choose the minimum number that is not there. I should choose 1. In here, I will choose the minimum number that is not there. I have to choose 3. But when you calculate the mixes at the end, you see that the mix at the first position is going to be 1. Then in here, it's going to remain 1. In here, it's going to be 2. And in here, it's going to remain 2. So you see that it's not what you were looking for. So this is an example of something that's not possible. The reason was that it was not increasing. When it decreases, it's not possible. Also, it's not only decreasing. For example, assume that we have 1 and then we have 8. How can we have our mix to be 8 in the second position? That's not possible. So that's also a negative. So if I put these values, I should put 0 here and 1 in here. And then I calculate mixes. I see that the mix of this one is 1, this one is 2. I see that these are not equal. So it's -1. If it's completely clear, we can move on to the next problem. Sure. Okay, let's quickly go over the next problem. The next problem that we're going to discuss is elements extermination. This problem says that you are given an array A of length n, which initially is a permutation of numbers from 1 to n. In one operation, you can choose an index I such that AI is less than A of I plus 1 and remove either AI or A of I plus 1 from the array. And so each time you can choose either AI or AI plus 1, it's a permutation such that AI is less than A of I plus 1. Each time you can either choose AI or A plus 1, A of I plus 1 to remove. You have to now say that at the end, can you make the length of this sequence equal to 1 or not? This is the next problem that we're gonna discuss. So for example, if you take a look at this problem, if you take a look at, for example, this case, you can, for example, at the beginning, take these 2 and 4 and remove the 2. And then 4 and 6 and remove 6. 1 and 3 and remove, 3 and 5, remove 3. 1 and 5, remove 1. 4 and 5, remove 4. Now I would like to know that, what do you think is the solution of this problem? Do you have any idea about it? Let's make it more. Let's share more. 0, 4, 1, 3. No, it's not the solution because the mix of the prefix of length 3 is gonna be 2, not 3. That's an answer for 1122, not 1132. Okay, so you know that each time you should choose two elements such that ai is less than a of I plus 1 and either remove ai or a of I plus 1. You have to say that you have to say that if we can achieve length 1 or not. This is a problem that can be solved very simply. And it would be great if you can solve that. Let me guys bring my charger as well. It seems like I'm running out of charge. Okay, sorry. Sorry for doing this in the middle of the stream. We will always remove bigger number. Why? Assume that I have 213. No. Yeah. Assume that we have 213. If you choose, for example, these two and remove the bigger number, then we are left with 2 and 1 and we cannot do anything. But if we remove 1, then we are left with 2 and 3 and we can remove another element. Guys, first of all, I want to give you, I mean, this is a problem that is theoretically very beautiful. And once you solve it theoretically, you see that the code is very simple. Guys, I say that, first of all, if A1 is greater than AN, there's no solution. It's negative 1. If A1 is greater than AN, it's always negative 1. Why? Because it always remains like this. If A1 is greater than AN, forever A1 is going to remain greater than AN with these operations. Why? Because if you do an operation that is not on 1 or on n, then it doesn't change these values. So it has no effect. If you do some operation that affects one of them, you are taking A1 with something that is greater than A1 and remove one of them. So either the first element remains the same or it becomes even bigger. Or if you choose the last two elements, you are taking an with something smaller than itself and remove one of these two. So the last element is going to either remain the same or become less. You can see that always your first element is always going to at least increase. I mean, at least do not change or it will increase, but your last number is always going to be the same or decrease. So if A1 is greater than AN, A1 forever is going to be greater than AN. And when you are left with two elements, you can't do anything and you cannot turn it into one. Because when you are left with two elements, definitely the first one is bigger than the second one. Is this clear? So the first thing that I will say is that if A1 is greater than AN, it's not possible. If it's clear, please put a plus or use this emoji. Awesome. Now the magic happens. What is the magic? Can you guess? Can you guess what is the magic? Can I repeat again? Yes. I'm saying that if A1 is greater than AN, A1 is always going to remain greater than AN. Why is that? Because in each operation, either you do not touch 1 or n, you choose 2 in the middle. Then A1 and AN won't change. If you choose A1 with something else and do operation on them, it means that A1 was less than A2 and you removed one of them. So the first element is either the same or it has increased. When you choose the last two numbers, it's AN and something less than AN. And when you choose one of them, you remove one of them, the last element is going to either remain the same or become even less. So I'm saying that the last number never increases and the first number never decreases. So you can always do an operation. Therefore, I mean, sorry, you can't reach one. It always remains at least two. I recently have lost some parts of my brain. My mind is in 1,000 places, unfortunately. Is it clear now? If it's clear, let me know. If it's not, also let me know. Clear now. Great. Now, what do you think is the magic? If A1 is minimum of all, then it is always possible. Then it is always possible. That's right, but we can say even something is stronger than that. Okay, they want to check my cards. I should be back. I'll be back. Okay, guys, can you hear me again? As I said, it's 12:30. I'm still at the university. At this time, people come and check to see if people here are allowed to stay, and only PhD students are allowed to stay. I should show my card so that they let me stay. Okay, so is it? Do you hear me first? Because sometimes my AirPods disconnect and you cannot hear me afterwards. Please ask me if you can hear me. Sound okay? Good. So, okay, what do you think the magic is here? I became expert, thanks. Really? Great. If you became expert, congrats. The magic is that otherwise we can always turn it into one. That's great. That's amazing. That if you already became an expert. That's really great. I hope that you enjoy being an expert. That's really great. I hope that I hear it from more of you. So the magic is here, guys. If A1 is less than AN, and they cannot be equal because it's a permutation. If A1 is less than AN, it's always possible. Why? Because, guys, A1 is less than AN. As long as A1 is less than AN and N is greater than 1, you can always find two indices such that the left one is less than the right one. As long as A1 is less than AN, you can always find two consecutive elements such that the first one is less than the second one. Why? Because assume that it's not like this. Assume that A1 is greater than A2. They are not increasing. So we cannot do an operation between A1 and A2. And then assume that we cannot do an operation between A2 and A3 as well. It means that A2 should be greater than A3. Then assume that we cannot do an operation between A3 and A4 as well. It means like this. You see that your array should be decreasing so that you cannot do any other operations. And it's not possible because we know that A1 is less than AI. So there's definitely two indices such that the left one is less than the right one. Otherwise, your array is decreasing, which cannot happen because A1 is less than AN. So as long as N is greater than N, when A1 is less than N, there definitely is two consecutive elements such that the left one is less than right one. And we can remove one of them. Which one? Remove the one that is not the first or the last position. I'm going to keep A1 and AN as it is, as long as N is greater than 2. When N is 2 and we only have A1 and AN, remove one of them. But before that, keep A1 and AN as one of these two. Before that, we always have middle elements. Try to remove middle elements. Is it clear? First tell me, is it clear or not? But then I'm going to also run it on an example. No. AN should only be greater than A1. And I will show you why. Okay, guys, someone give me a random permutation. Oran, are you here? If you are here, give me a random permutation. I just randomly use your name. Okay, we have, that's not a permutation though. But it's not that important because it's still the numbers are distinct. But it's okay. Can you guys give me a bigger permutation? Or if you continue your permutation, it's going to be great. I want to show it to you on a big permutation. I mean, if you actually have 9 elements in your permutation, I can continue this. It's okay. As long as we have 1, 7, 3, 5. I wrote this, so I have to continue now. 9, 1, 7, 3, 5, 9, 8, 2, and what is left? 6, and we have all 4. I hope that you can see it clearly. Sorry that I'm writing it on the chat box, but instead I can see you on the same at the same time. Then I say that because 1 is less than 4, there definitely is 2 consecutive elements such that one of them is less than the other one. For example, these two have this condition. I will remove one of them. For example, I remove 3. They don't matter because I just want A1 and AN not to change. That's the only thing that I want. 2 of you got the same? Interesting. Interesting. And then still we have 1 and 4. So definitely there are 2 that they are increasing. Again, 5 and 9. So I will remove 5. Then again, we have 2 consecutive that one of them is less than the other one. For example, 7, 9. The first one is less than the other one. So we remove 9, for example. Then we have 7 and 8. We remove 7, for example, this time. Then we have 2 and 6. We remove 6, for example. Then we have 2 and 4. This time, I will make sure that I will remove 2 because I don't want to change AN. This time, if I change AN, because it's going to be 2 still, it's okay. But I want to make sure that I will not change A1 and AN until I have only those 2 left. And I'm going to have 1 and 8. Again, I'll make sure to remove this 8 because I don't want to change A1 and AN. You see that at the end, I'm going to be left with these 2 elements. And then when we have 2, we have these 2 left. We are going to make it into 1. Do you see it or do you want me to write it again from the beginning on the whiteboard? Did you understand this or not? Again, if you understood it, please put a plus. If you didn't, put a minus. If you want, I can do a easy example on whiteboard. I can probably also show it to you here that you can see it better. Maybe on this background you see it better. So each time I had 2 consecutive elements such that the left one is less than the right one. As long as A1 is less than AN, such a pair exists. And we can remove one of them, but we want to keep A1 and AN intact. So this way we can make sure that it always remains as root. Okay, great. So if it's okay, let's quickly, okay. So let's not quickly go to the next problem. How do we claim that we will always have such pairs to remove? I said that because A1 is less than AN. As long as A1 is less than AN, we definitely have 2 consecutive elements such that the first one is less than the second one. As long as A1 is less than AN, we're going to have 2 consecutive elements such that the first one is less than the second one. Why? Because if it's not like that, your array, you see that it means that your array is in decreasing order. If for each 2 consecutive element, the later one is less than the current one, it means that your array is in decreasing order. But it's not possible because A1 is less than AN. So there definitely exists a pair of consecutive elements such that first one is less than the other one. This is a very famous thing, guys. And that's one of the patterns that you are seeing in this problem that actually is going to help you in similar problems in the future too. But that's something that you see multiple times in the future. I mean, if your array is non-decreasing, there definitely, clearly, if it's not decreasing, it means that at some point it's not decreasing. So the one after is greater than or equal to the one before. So here, because it's a permutation, it's strictly less because they cannot be equal. So there will be, as long as we have at least two elements, there will be two elements such that the first one is less than the next one. And each time we can remove, I mean, we can choose these two and remove, we can choose these two and remove one of them such that A1 and AN are not changed. No, we are proving it actually by mathematically and theoretically proving it. And then the final solution is going to be as simple as this. We're going to get AI. Let me see that when I accepted it. Oh, I accepted it very recently. That's not very recently, actually. It's more than 5 years. But on my timeline is recently. I just see in AI, as I say that C, if A of 0 is less than A of n minus 1, C out yes, otherwise no. That's it. All this problem was all theoretical. The practical part is as simple as this. Is it clear now? If there's anything not clear, let me know. Otherwise, we'll move on to the next problem. And by the way, great job, Moridul. If I'm pronouncing your name right, I hope that I'm pronouncing your name right. You accept. I remember that before adding new problems, you accepted all of them, which is great. I'm really glad. And we have another person who has also solved all the problems. I don't know if his real name or not. Jose. Jose. That's great. Great job, guys. And I see that the rest of you, there are some people who have almost solved all the problems, which is really great. I mean, I'm sure that you guys can really grow well if you continue doing this. Now I understood, and I know by now, for reaching a sphere, we need to prove our approximate. Yes. Yes, that's right. I mean, you should have an idea that, okay, why it works. Otherwise, there's a high probability that it would get the wrong answer. Yes, it always gives a solution if A1 is less than AN. We always have a solution if A1 is less than AN. Because as long as N is greater than 1, you can remove an element and keep A1 less than AN. So that's then the solution exists. Let's move on to the next problem, the number of products. It says that you are given a sequence A1 to AN consisting of n non-zero integers. You have to calculate the following values. The number of pair of indices like L and R such that AL to AR is negative, and the number of pairs of indices L and R such that AL to AR is positive. You have to calculate these two. You have to say that how many we have. I have a small feeling like my voice might have a problem, but because you're not saying anything, I guess it's okay. A great concept-based question. Great, glad to hear that. I did a very nice problem yesterday. Okay, it just brought an idea to my mind that maybe we can also have a suggestion section that people can suggest what problems to solve. But that's actually something that Teams section does that as well. Guys, again, I invite you to attend the Teams. As you can see, 32 members created a group to reach pupil. That's great. And we have 6 people as well to reach candidate master. That's great. And we have 44 people who joined Build and Learn with Repovive. And we just created our Discord server, and I'm going to engage with you guys in our Discord server and talk to you personally, one by one. And then we decide together how to move on together. So, yeah, that's great. Rate of the previous problem, I think it was either 1400 or 1500. Yep. Let's move on to the next problem. Okay, so in this one, I know that I should just count that how many of them are negative, how many of these products are positive. So basically, what do I say? I say that first, the numbers do not matter, only their sign matters. So I can turn all these numbers into 1 and minus 1. So the first thing, 5 can turn into 1, negative 3 can turn into negative 1, 3 to 1, negative 1 to negative 1, 1 to 1. So because the values do not matter, it's just the sign that matters. So I can change the values to 1 and negative 1. Do you guys agree with this? Oh, I way to join the team. Great. Send a text message when you arrived. Last week at Coders, C and D problems were also good. Good. I can add a section that you guys can suggest problems. Although, as I said, it's kind of is similar to the team section because it's actually engaging together, and you can do it there too. But I mean, that is also possible. Okay, so let's get back to the solution. So guys, now that we turned it into this, do you remember that we talked about prefix sum in our previous session yesterday? We talked about prefix sums, right? We said that a prefix is, a range is gonna be like, this prefix minus this prefix, right? We said that a range is like this prefix minus this prefix, right? Now it's a product. So what can we say about it? I mean, when is this negative? When is the product in here negative? Tell me that. When is the product in here negative? Solution should be between teams. We need your problem. Okay. There's a concept of making minimum permutation by. Interesting. When there's odd negatives, yes, but also what can you say about these about prefixes? How can you use prefixes? Division gonna exclude. Yes, we can say that division excludes. So it's like the product of here is gonna be the product of this prefix divided by product of this. But the main thing, yeah, all things that you say are right, but I want to use these prefixes. So what I say is this, is that this product is negative if and only if the sign of this prefix is different to the sign of this prefix. This means that, why? Because do you agree that this prefix is the product of this prefix and this range? So if the sign of these two, their signs are different, then it means that this was a negative thing. So that's when this multiplies by this, it changes the sign. So this section is negative if and only if these two prefixes have different signs. Do you guys agree with this? So I only say that a range has a negative product if and only if these two ranges have different signs. Do you guys agree with that? There's an issue with that. I should fix that too. That issue should be fixed. We will work on that. Okay, great. So in the same way, when is this range positive? When is this range positive instead? So in the same way, I want to know that when is this range positive? Both positive, same. Yes, if they are same sign. Either both of them should be negative or both of them should be positive. So if it's different signs, if these two prefixes have different signs, it's going to be negative. If both of them have positive sign, if both of them, if they have different signs, it's going to be negative. If they have the same sign, it's going to be positive. And that's all. So if I calculate that, how many prefixes have negative signs and how many prefixes have positive signs, I mean, each prefix, you can take a look at the previous prefixes and see that how many of them are the same, how many of them are different. The ones that are same create a positive range with us. The ones that are negative, I mean different, they create negative with us. So the solution will be very simple. The solution would look like this. I mean, we have a 4 seen AIs, and we have a C of 2 where we calculate that how many positive prefixes we've seen, how many negative prefixes we have seen. At the beginning, we have an empty set. Don't remember, guys, this fact that we also have an empty prefix as well. You have to also always consider this empty prefix, because if your range is a prefix itself, then it's going to be this prefix and empty prefix being excluded from the beginning of it. Empty prefix should be so. So you should always consider the empty prefix as well. Initially, car is positive. So initially, I add 1 to the C of the positive numbers. And then each time I say that if A of I was negative, I will toggle car. So if it was positive before, now it's negative. If it was negative before, now it's positive. And then I say that ans of 0 plus equal to C of car, ans of 1 plus equal to C of the inverse of car, and then C of car plus plus. I wrote it in a very complex way because back when I wrote them, I didn't know that someday I'm going to explain it to many people. But that's actually the idea, that as we are going forward, we are saying that, okay, this prefix has a positive product or a negative product. We keep the count of them. And each time we see that, okay, previously, how many of them are different, how many of them are the same. And we keep adding that. Also, we can see that how many positive prefixes we have, how many negative prefixes we have. If we have A positive prefixes, B negative prefixes, the number of negative ranges is going to be A times B. The number of positive ranges is going to be A choose 2 plus B choose 2. Because for a negative range, you should choose one of the positive ones and one of the negative ones. And it doesn't matter if the positive comes first or the negative. They should just be different. And for the positive ones, either you should choose 2 of the positive ones or 2 of the negative ones. This also works. Is it fully clear? If it's clear, please put a plus or send the 100 emoji. If it's not clear, also definitely let me know. If AI can be positive, is it hard? If AI can be positive, what do you mean? You mean if AI can be 0, I guess. Can you explain the second concept again? Yeah. What was the second concept? I said, okay, you mean the second solution. So I said that if we have A positive prefixes and B negative prefixes, the number of negative ranges is going to be A times B. The number of positive ranges is going to be A choose 2 plus B choose 2, because we either choose 2 positive ones or 2 negative ones. That's the same thing that we either choose 1 positive and 1 negative or 2 of the same parity. That's all. If we had 0, yes, it would be a bit more complicated because a lot of ranges also would have a 0 product. It would be a bit more complicated. Actually, at the end, you should have calculated that how many of them are 0 and remove them from the range. It would be a bit more challenging, yeah. Great solution. Great to hear that. And guys, if you had any additional questions, definitely ask your questions in the discussion section and I will answer them. Definitely. So if you had any questions, make sure to ask it there. And if you haven't already, make sure to click on this I mean button so that you will be added to problems and you can see the discussion and everything. Okay, let's move on to the next problem very quickly. This is the speed that I think you will enjoy it the best as well because we are at maximum efficiency. So guys, we cannot have a camp about reaching experts and we never have a graph problem. So we should talk about graphs too. This is the first problem that we're talking about, and it's about graphs. It says graph without long directed path. It says that you are given a connected undirected graph consisting of n vertices and m edges. There are no self loops or multiple edges in the given graph. You have to direct its edges in such a way that the obtained directed graph does not contain any path of length 2 or greater, where the length of the path is denoted as the number of traversed edges. So we should direct the edges in a way that we will never have a path of length at least 2. Okay. Yes. Thank you very much for sharing. I think we solved Greg and Ari yesterday, right? This was, yeah, it was here. Okay, let's get back to this. We want that we don't have a path of length 2 or more, right? So how do we make sure of that? Well, how does a path of length 2 look like? Do you agree that it's going to be a middle vertex, that it has an input edge and an output edge? So if we have no directed paths of length at least 2, what does that mean? Can anyone tell me what does that mean? What can we conclude from it if we have no paths of length at least 2? What can we conclude? Tell me your idea about it. Disconnected. Uh, Kind of, but because it's an undirected graph, I wanted to say it in another way. I mean, it's not very clear what you mean by disconnected. That's not what we are looking for exactly. We cannot traverse the whole graph, more than one connected component. So you're all saying the same thing. You know, component is hard to define in a directed graph. What do you mean by components? You might say that component, for example, you mean strongly connected components. In directed graphs, you have strongly connected components, not connected components. Or whatever else that you mean. Strongly connected components, you might have heard about it. It's called SCC. I mean, you might have seen SCC. Thank you, man. Degree at most 2. No, it's a directed graph. So we might direct it in a way that it won't be like this. Yeah. So this means that there shouldn't be any vertex that has an incoming edge, and has an outgoing edge. There shouldn't be any vertex that has an incoming edge and an outgoing edge. Because if there is such a vertex, then we have a path of length at least 2. If there's a vertex that it has an incoming edge and it has an outgoing edge, then we clearly have a path of length 2, right? So what does that mean? It actually means that in here, that for each vertex, you either should turn all of its edges going in or make all of its edges going out. It's one of these two ways. Either all of the edges coming in or all of the edges going out. It's one of these two cases. Do you guys agree with this? So that was the answer that I was looking for. For each vertex, either it should be, I mean, all the edges should be either incoming or outgoing. If you agree with this, please put a plus. Otherwise, put a minus in the chats. I was also looking at something. Okay, good. Great. So that's what we need to realize. I mean, we need to understand that. And guys, what we can do in order to find that out, we basically need this. We need to find out if the graph is bipartite or not. Why? Because if the graph is bipartite, what does a bipartite graph mean? A bipartite graph means a graph that we have two parts such that all the edges are between these two parts. It means a graph that all the edges are between these two parts. What are the real world examples of this? For example, if you have n men and n women and they want to like marry each other, for example, we can see that which pairs of them can marry each other, for example, or other things, anything else, right? So basically, a bipartite graph is a graph that we can have two sides such that all the edges are between these two. Now, if we can find out if we have a bipartite graph, then we can, for example, make all of the edges going out of these vertices and coming into these vertices. So it's like we direct all of these to the other parts, to the parts below. And then we have the condition we want. We will have no paths of length more than 2. That's actually this. If we can do this, it means that the graph is bipartite. Because if we put all the vertices that their edges are outgoing on one side, and all the vertices that their edges are incoming in one side, all the edges should be between these two sets. There can't be an edge inside, right? So all this problem turns into is the graph bipartite or not? It's great to learn. Thank you. I'm really glad to hear that it's actually helping you guys. So all we need to find out, all we need to figure out is to understand if the graph is bipartite or not. Thank you very much, guys. We need to find out if the graph is bipartite or not. Now the question is that how do you figure out if a graph is bipartite or not, which is a very famous problem. And we're going to talk about it now. Yeah, the solution is very simple. Just start from one vertex and say that, okay, assume that it's in group 1. Group 1 and 2 have no difference. For example, assume that, okay, this is in group, we have two parts. We want to find out if a graph is bipartite or not. Let's say that this is in parts 1. Then, in your DFS, you can do a DFS or BFS. For example, DFS, you make all the neighbors be in the group 2. You have to make them be in the group 2. And then for everything next to these, you make all of them 1, and so on. So each time when this vertex has a color C, you make the color of its neighbor 3 minus C. So that if it's 1, it becomes 2. If it is 2, it becomes 1. 3 is 1 plus 2. I say 1 plus 2 minus C, such that whichever of 1 and 2 is, it will turn into the other one. So always it should be 3 minus C if the color of this one is C. And if at some point you reach the point that you see that, oh my God, this is C and its neighbor is also C, that's bad. Then we're in a bad position and it's not a bipartite. Right? That's all. Yes, the bipartite part says that if you put all the outgoing all the vertices with outgoing edges on one side and all the vertices with incoming edges on another side, all the edges should be between these two. We cannot have an edge between two of the vertices that both of them need their edges to be outgoing, right? And we cannot have an edge between two vertices such that both of them need their edges to be incoming. So we changed the shape of the problem statement so much, and we turned the problem that we have to simply ask if the graph is bipartite or not. Because we said that the vertices that their edges are outgoing are one side, the vertices such that their edges are incoming are another side. And then the implementation would be as simple as this. You will get the inputs, the graphs in the inputs. We keep all of the edges, and we have a for on all of the vertices. If you see that a vertex is not assigned a group, you put it in, for example, in group 1, and you start a DFS. In your DFS, you will have a for on all the neighbors. If a neighbor is not seen yet, you will make its value to 3 minus value of v, and you will run DFS on it. Because its value should be different than the value of me. What is this 3 here? 3 is 1 plus 2. So I set value of u equal to 1 plus 2 minus value of v. This means that if value of v was 1, make value of u 2. If value of v was 2, make value of u 1. So it's actually 3 minus value of this one. And then DFS of u. And if value of u was equal to value of v here, that only happens if value of v is not 0 here, it's already assigned. And we say that it's equal to what we have in here. And then we see an edge between two sides that are in the same group, which is a contradiction. That should not happen. And we know that everything that we did, we were forced to do that. I mean, other than the parts that it doesn't matter. Like, for example, we have a vertex that is not seen yet, and we put them in one of the groups. In this case, you will see out no. Otherwise, you will see out yes, and at the end, you can just see that for each xi, what is the value of xi. If the value of xi, if xi, for example, was in the first group, for example, you can say that this edge is incoming. Otherwise, if it's in the second group, you can say that this edge is outgoing. That's great to hear. Sure thing. I hope that you understood it really well. Is it clear, guys, for everyone? If it's clear, please put a plus. If it is not, please put a minus or let me know in any way. Let me also go to full screen, make my video full. And Oran, if you are here, you didn't remind me to say it in the Telegram channel. And I forgot it. You had to remember me. You had to remind me. I forgot to say that in the Telegram channel that we have started our live stream. Could we just go over the whole solution again? Yeah. You did? You told me? I didn't hear that then. So, okay. So let me tell you the whole solution again. Guys, I'm saying that we have two types of vertices. If we have a path of length, why? Because if we have a path of length at least 2, yeah, I didn't see that. If you have a path of length 2, if you consider the middle element, it means that if for a vertex, it has both incoming edge and outgoing edge, it means that we have a path of length 2. So each vertex, either all of its edges should go outgoing or incoming, one of these two ways. All the edges of each vertex should be either incoming or outgoing, okay? And then I say that, okay, let's consider all the vertices with edges being outgoing in here and all the vertices with edges incoming in here. Then we know that all the edges should be between these two parts. No edge can be completely in one side, because then we don't know to which direction we draw it. Therefore, our graph should be bipartite. So we need to figure out if the graph is bipartite or not. And what can we say about that? What we can say is that, okay, we have a graph, we want to find out if it's bipartite or not. We can start from a vertex and make its color, for example, 1. And then for each of its neighbors, make its color 3 minus the color of this one. And go over all of them. At the end, each of them will be either in group 1 or group 2. Then you have the vertices in two groups. Then for each edge, you can make sure that this edge goes from group 1 to group 2. And then you can be sure that you don't have a path of length 2. Which topic would you say is most important in your opinion in CP? In general, I think DP. DP is, I believe, the most important thing. But graphs are definitely very important as well. Is it clear now? This is the solutions. Is the solution clear? Why 3 minus V? Because if the color of V is 1, the color of the neighbor should be 2. If the color of V is 2, the color of neighbor should be 1. No, 3 minus V is that, see, we need something that's, if the color of V is 1, the color of U should be 2. If the color of V is 2, the color of U should be 1. So whatever the color of V is, the color of U is 3 minus that. If it's 1, that's 2. If it's 2, that's 1. That's all. So if you have two values like X and Y, and you have a Z, you have a Z, and you want to, and you know that Z is either X or it's Y, and you want the other value that Z isn't, you can easily say that, okay, X plus Y minus Z. That gives you the other value. Then if Z is X, this formula gives you Y. If Z is Y, this formula gives you X. So we have 1 or 2, and we know that the color of this one is either 1 or 2. So just write it as 1 plus 2 minus that. So it gives you the other value. Yeah. Is it clear? How to actually get good on DP. Have you watched the DP topic streams? I think it can be very useful. Because I talked in detail about all of everything about DP. Is there some way to connect with you to discuss and take some advice? I don't want to waste your time here on stream. Yes, definitely. You can. I mean, that's why we have this discussion parts. That's why we have this discussion parts. In here, you can come and write your questions. I see that we have 2 questions that are not responded. In here, whatever question you might have, feel free to ask them here. That's actually great. And everyone else can see your question as well. And they can like your questions and try to like each other's questions so that the best questions that are most interesting for you come on top. So definitely, yes. I mean, that's exactly why we have this discussion section, so that I can answer your guys' questions. And guys, by the way, this is November 10th. I mean, now it's EST time, Eastern time is November 11 because we're after midnight. And I think your time is also November 11. But California time is still November 10. And our goal was to reach 1,000 users till November 10. But as you see, we are at 876 right now. So just tell me what help you can do to me to reach 1,000. I want to make sure that before this, okay, I think the voice is lost. Can you hear me? The voice was lost for a second, I think. Yeah. So how do you think we can achieve this? Do you guys really know people who might actually benefit from CP? I know that I asked the ones of you who were in the stream yesterday, I asked you, but I know that there might be some other people in here today. We need a push from you guys in order to make sure that we get to the goal we set for ourselves. We said that, okay, in 10 days, by November 10, we will reach 1,000. We're just a bit below. I mean, just a bit. Hopefully together we can really create a really, really great community. I can put it on LinkedIn. How many uh, followers do you have on LinkedIn? How many followers each of you guys have on LinkedIn? That's interesting. I have, I think, 8,000. But I didn't post on LinkedIn myself. I prefer to talk in person with everyone to get feedback from them. But I will. I haven't put a post on Codeforces as well. But I might write a post on Codeforces as well because then definitely many people can see it. Guys, the funny thing about Codeforces is this. There's a guy who I know him. Many people told me about him to me. There's a guy that whenever I put a blog on Codeforces, for some reason that he knows, signs in with multiple accounts and just downloads it. I don't know why. I really can't understand why. But each time, for example, for solution discussions, when I post on Codeforces, it starts to increase. I mean, it starts to get, for example, plus 10 or something. And then it's like that guy becomes online. Then it jumps down, for example, to negative some big number. And then when he does his work, then again, slowly it tends to go up again. I don't know why. But I mean, it's just sick. I just don't understand. For some reason, I don't know. You sometimes don't know what have you done to some people. But for some personal reasons they have, and I know who that guy is. I mean, many people, each day new people come to me and say that, yeah, this guy is doing this. It's just, I don't really care about this guy. I mean, it's like we are trying to build amazing stuff, and some people, all they do with their time is just doing this stuff. I mean, the time that we spend on building great things, they spend on these things, doing these acts. I prefer not to share his ID. Many of you, if you are in these Discord servers, you know him because in these Discord servers, they talk a lot about him, looks like. Yeah, I get it. You noticed it. You also noticed it. So it's not just me or notice it. This pattern always repeats. No, he's not my opponent in anything. I mean, I don't know the guy, actually. I just I think I just have talked with him like once and that's it. And I don't really even remember for what was that. But the guy was so much into, for some reason, he was just so much into doing this. Yes, I mean, some people are really, I mean, this is the same as guys. I wanted to always talk about it. I even wanted to write a CF post about it. That maybe I will write. I still maybe write it. Not to just talk about this guy, but I wanted to talk about the people who do cheating on Codeforces. See, there are some people, I mean, at the same time that you are trying to build something. I mean, we have a bootcamp now, and you have participated in this bootcamp. Why? Because you are trying to build skills. You are building something. So we have something in common. We want to build something. At the same time that we are trying to build something, there are so many people, like the people who cheat in contests, or people who do, for example, spend their time doing this stuff, or many other things, that spend time on such stuff. At the end, who do you think will achieve something valuable? No, he's not Iranian. He's European. But my point is, at the end, who really you think achieves something big? You guys who are trying to build something, or people who try to just cheat? Each contest they cheat. Do you think they are going to really achieve something? Actually, what they're doing is actually just wasting their time. There's nothing other than wasting their time. So I actually had the idea of writing about this guy and to get a philosophical outcome out of this. That's it. I mean, sometimes we are just building and putting our time on building valuable stuff. At the same time that some people are just into these and that's the only thing that they do with their time, which is crazy. I mean, I can never imagine myself putting my time on that. Yes, I mean the time that you put on cheating, for example. I mean, what do you achieve after that? It's actually, at least if you achieve something, I can say that okay, I can understand that's why you did this. But sometimes this is like you don't even understand what does this person get. It's some sort of sickness. I don't know. For example, it's a trauma or something like that. So I cannot really understand it. I did my university studies in Sharif University in Iran. Yes, these people either affect other people's rating or anything else. They want to just affect others. And they actually, the only harm that they can do is that we start talking about this. But it's not actually a harm. I mean, there's really a lesson in it. I really believe that there's a lesson. I mean, at the end, the ones who actually own the future and can do something big are you guys. Because you're actually building things. You're doing things the hard way. You're not cheating. You're not trying to create fake stuff. You know, that's the important thing. We are not trying to create fake stuff. That's the important thing. Some people are just into those things, and that's not valuable. Some of us are doing the things correctly and in the hard way. We are spending time, we are spending energy. But some people just want to do stuff in the wrong way, and that's it. Okay. Yes, definitely interviews. I mean, competitive programming has so much effect in interviews. So, yeah, that's it. But anyway, if you are ready, let's. I mean, again, I would love it if you help guys. I mean, by LinkedIn posts, sharing in groups that you have. And guys, let's do something interesting. If you wrote a LinkedIn post, mention me in it as well so that I see it. And I will definitely comment on your post. And thank you for that, for doing this. I already received a lot of posts that mention me. I mean, like once every 2 weeks or so. That would be really great. I mean, if you want to. I mean, and if you believe that there are some people who actually benefit from Repovive. And if you did that, if you wrote a post, definitely mention me or the page of Repovive so that we can see that. And thank you for we can thank you for doing that, for introducing Repovive, spreading the word. That's very meaningful. Yes, that's right. But it doesn't matter. I mean, you shouldn't waste your time about that, because at the end, I'm telling you, you think at the end you are gonna build something valuable, something real, or they are gonna do. The ones who put real efforts. Right now we are spending energy. I'm spending my energy and time. You are spending your energy and time to build something valuable and meaningful. That's the most important thing. 474 connections is actually a lot. I mean, that's really great. Thank you very much. No way I learned from ChatGPT. Is it good? I also learned from ChatGPT a lot, so I cannot say it's bad. Yeah, I actually like that. We'll have to share Repovive with these cheaters so they can learn. Yes, share Repovive with the cheaters. Repovive is a place that cheaters should change their approach and start learning, actually. Okay, so let's move on to the next problem. The next problem is as simple as one or and two. It says that you are given a non-empty string s equal to s1 to sn, which consists only of lowercase Latin letters. Polycarp does not like a string if it contains at least one substring, one or at least one substring two. So if we have a substring, I mean 3 consecutive characters that are exactly ONE or TWO, then we don't like this string. Otherwise, we like it. You have to say that what is the minimum number of characters that we can remove from our string so that it would actually be a good substring. Okay. You have to say that what is the minimum number of indices needed for that. So, what do you think we can do it here? Guys, this is again another very good example of dynamic programming. If you have sub-dynamic programming problems, by looking at this problem, it gives you a feeling of dynamic programming to you. Yes, exactly. It smells a bit like DP. Why? Because each time we have one of these situations. We have a prefix, and we each time have a prefix, and the last characters of it, we have one of these situations. Either we're in a position, for example, assume that we're in a position that the last 2 characters were O and N. If the last 2 characters were O and N, then, for example, this character cannot be E, right? So we have several states for the last characters. Either the last 2 characters were O and N, or the last characters were not O and N, but the last character was O, or the last 2 characters were T and W, or the last character was T, or none of these. We are in none of these states. I say that each time we are in one of these 5 states. So we have 5 possibilities, dp of I, and 5 situations. 0 means that there's nothing dangerous. 0 means that there's nothing dangerous. I mean, the next character can be anything. 1, for example, 1 can mean that we have only O. If an N will be added to it, we're going to have O and N. If anything else will be added, it will be discarded. If O itself will be added, it remains as one O. So it either goes to itself or goes to ON or other cases. And the state 2 can mean that the last 2 characters are O and N. State 3 means that, for example, the last character was T. We have considered the first I characters. The last character that remains, the last character that we kept is T. And 4 can mean that the last characters that we kept are T and W. You just know that when you see a new character, one choice that you have is to erase it. It will cost 1 and your state remains the same. If you just erase the new one, your state remains the same. If you don't erase it, you can easily see that to which state you can go. From 0, with O you go to state 1. With T you will go to state 3. And with all the other characters you remain in state 1. From 1, with N you will go to state 2. With O you will remain in state 1. And with anything else you will go to state 0. From 2, you cannot have E. So if it's an E, you cannot do anything. With anything else, you will go to O. With anything else, with anything like O, with O you go here. I mean, not with anything else, sorry. With O you go here, and with T you go to here. Also from this one, with T you go to here. And the same things about this. From this one, with W you go here, with O you go here, with anything else with t, you go here to itself. With anything else, you go to state 0. So I'm saying that if we add a new character, we can easily see that to which state we can go. And this can easily give us a DP that can be easily updated, and it can help us calculate the solution. So for each prefix, there are only 5 states that you need to consider, and that's all. Is it clear? Or not? I will also show you the code. But let me first ask if it's clear so far. Or not. Yes. Yes. I I will go over it by showing it on the code so that you show the code, you see the code this time as well. It helps. Let me see, when did I write this code? It's weird. This is a very long line. So what have I done? I think that my solution is not, I mean, my code is not a very good code. I don't know what is this doing. Maybe let's show you another code for it. Basically, guys, I say that at each position, you need to see that how much you're in danger. At each point, you need to know that how much are you in danger. So basically, what? I mean, the solutions that these guys have are different. For example, this is not DP. The solution that we want to talk about is the DP solution one. Let me find someone who has done the DP. Okay, I'm not fine. People have not used the DP one that I want to say, so I cannot show the codes unless I search more. That if you want, I will search more and show one of them to you. But all I'm saying is that at each state, for each prefix, there are 5 possible cases. I mean, 5 possible states to know that how much are we in danger. We're either if you consider the last character, either it's nothing dangerous in them. For example, assume that the last character was Z. Then we are in no danger. I mean, we are not close to make it 2 or a 1. Okay, we're not close to be a 2 or a 1. But it's possible that you have constructed part of 2 and 1 already, and you should now be cautious that to not make them full and create 1 and 2 completely. One of the cases is that if you have a single O at the end. One of the cases is that if you have an O and you also have an N. One of the case is that the last character is T, and the other case is that the last 2 characters are T and W. We have these 4 cases along this one case that is just something random. For each case, when we go to dp of I plus 1, we either give cost 1 and remove the next character, by which we remain in our states. Or we can add this character. If we add this character, it's easy that from each state, we will go to each state by which character. For example, if I'm an O and I see a T, I will go to this state. Because now my last character is T. If I'm an O and I see an N, I will go to this state. If I'm an O and I see an O, I will remain at state 1. If I see anything else, I will go to this. If I'm at T and I see an O, I will go here. If I see a T, I will remain here. If I see a W, I will go to this state. And anything else, I will go to here. From T and W, I should not see an O. So if it's an O, I cannot do anything. So I will not update that. If I see a T, I will go here. If I see a O, I will go here. If I see anything else other than O, I will go here. Sorry, I cannot have a O. Sorry, I forgot this. I cannot have a O. If I see T, I will go here. Anything else other than O, I will go here. If I'm on this with a T, again, I can go here. With a O, I can go here. And with anything else other than D, I can go here. So this is how we can go to other steps by adding a new character. So this is how you can see that what is the next value of j. If you are on DP of I and j right now, what is the next value that you can be on? Does it make sense? Yeah, I can show you the editorial as well. So I'm sure you'll find the solution. Okay. You go over here. Char should be any five of the char A and then check. No, from each state of DP of I and J, I see that what I want to add to it. And among all of the things that I want to add, I see that with each one, where do I go? I see that which place will I go from each one of them. And that's all. So I can basically, let me take a look at editorial as well. I'm sure that this problem has easier solution without DP as well. That we can probably have even greedy solutions. But we were looking for the DP solution in here. So let me tell you about the other solution as well, if this solution is different. It says that this problem is designed by Mike, by the way. Two substring 1 and 2, obviously, at least one char should be deleted in there. The only way they can intersect is that we have a 2 and a 1 afterwards, exactly. Thus, the answer is no less than the value of 3, C of 2, 1 plus C1 plus C2. C of 2, 1 is the number of occurrences of this. Yes. And C1 is the number of occurrences one string, which are not parts of this, and this, yeah. Yes. So he says that let's just count that. How many ones do we have? How many twos do we have? These do not intersect. These ones and twos do not intersect. All right? The odd only case that they intersect is like this. In these cases, we can remove 2 and 1 by removing this O. But in all the other cases, for each of the strings of 1 or 2 that we have to remove them. So the only thing you can say is this. Let's just take a look at all of the occurrences of 2, 1, and this way that 2 and 1 intersect with each other, and just output the number of these plus the number of these plus the number of these. And these ones are the number of ones that we have that are not part of this. And these are the number of twos that we have that aren't part of this. Does it make sense? The owner of CF. Yes. Mike is a very nice guy. I really, really like him. He even gave me a happy birthday message in late October. Late October was my birthday. And guys, how old do you think I am, by the way? In October 27th, I got to a new age. I think some of you know already. If you remember from the last times that we had chats. 26, right? I was 25. I'm now 26. Anyway. I hope that, guys, it was clear. I don't want to also make the live stream very long. So let's conclude this. If you have any questions, tell me about it. It's 1:40 a.m., right? I don't know if you can see the clock on top right of my screen, but you can see time EST. It's 1:39 a.m. What? October 27 is your birthday too? Soon, hopefully. Well, I want to reach 1,000 users. So actually, as long as we're not 1,000 users, I cannot leave. And with the speed that we are going right now, it's going to take a lot of time because we're still far. But the number is really beautiful, 888. But I need your help. If you want me to sleep, help me with that. Please help with sharing Repovive with others so that we reach 1,000 and I can actually leave and sleep. Uh, yes, but I think it's better if we don't. I mean, it's doesn't. I mean, the time that it will add to do that, its cost is more than the value that it has. That's what I think. I think that, as I told before, I want to set some fixed time for the live streams, and that's actually something that can help to have it the best effect. That's why I prefer if we don't do that. If you did, if you did not fully understand the DP solution, I really recommend you to watch the that section again, or try to understand this other solution. This also other solution also works. So it's also okay if you solve it with this other solution. Does this work by any chance? I hope that that's okay. Yeah, sorry for that. I am posting on LinkedIn. Thank you. That really means a lot. Okay, great guys. The greedy solution is very good. Yes, the greedy solution is very good. Guys, I really hope that you understood it. Make sure to accept this problem till tomorrow. Remember our pact. Our pact is that all of you who participated in this camp, you should have a level up in your rating. So make sure to accept all these problems so that we can achieve this. Okay. Let me know if you have any other question. Hopefully. Hopefully. Okay, guys, and as I said, the contest, Repovive contest, we had to postpone it. I should maybe write a post that this is postponed, and hopefully see you guys tomorrow as the fifth session of the camp. So far, if you want to rate the camp from 0 to 10, how do you rate it? Share it in the Telegram channel. I will put a vote right now. Let me bring the Telegram channel. Let me write it just right now. Let me bring it back. A poll. How do you rate the bootcamp, the Codeforces level up bootcamp so far? Scale of 0 to 10. 10, 9, 8, 6 or 7, 4 or 5, 2 or 3, 1, 0. Check the results. You can vote here, and I'm gonna see the results. 9.5, 9, 10. That's great to hear. That's great stats if it was really that helpful. Awesome. Great. Yes, I'm gonna try to choose the best problems that can actually help you guys, and I hope that it is really doing its purpose. Thank you guys for joining. Again, if you know anyone who gets benefit from Repovive, definitely introduce Repovive to them, share Repovive with them. That would really help us shape our community. So I would really appreciate if you do that. And also, I'm trying to make it more engaging and you guys can spend more time on it. I mean, can do more, actually do the goal that we have in it. So try to see that if, as I said, one of the problems we want to solve is that we can make a bridge between you guys so that you can know each other. So I would definitely invite you to use this Teams feature that I believe that can really, really help and that can become really something amazing. Okay, guys, again, thank you so much. I'm gonna Yeah, that's great. Thank you so much. I would really appreciate it. Thank you. I think that that is really valuable for us, for all of us. I mean, Repovive is the community of all of us. Already, I know that many of you wanted to join the team of Repovive, and it's open to you. I mean, it's your community completely. Thank you, guys. See you. Bye.